Okay, so this video will be discussing the Statistics 1 paper for February-March 2021, paper 5-2. Okay, so question number 1. We have a fair spinner, and then we have 5 sides for the fair spinner, and the number are 1, 2, 3, 4, 5, and then it is spun repeatedly. The score on each spin is the number on the side which the spinner lands. Okay, first they want us to find the probability that a score of 3 is obtained for the first time. So highlight the keyword first time. When you see this kind of question, right, where they tell you that, oh, maybe something happened for the first time or something appear for the first time, okay, so or the first 3 is appear or obtained for the first time on what? So all this kind of structure, it belongs to geometric distribution. Okay, so for geometric distribution, you have a P, the value for P. So we'll focus on the event of the P in the question, where here they are talking about a score of 3. So a score of 3 is, that means the probability for to obtain a 3 for any single spin. Okay, so for here P will be, to get the 3 will be 1 over 5 because it is a fair spinner, right, with 5 different numbers. So to get the score of 3, the probability is 1 over 5 for a single spin. Okay, so this is the number of spin. Is geometric distributed with the P, which is 1 over 5. That means the probability of not getting a score of 3 will be 4 over 5. That means you might get 1, 2, 4, 5. There are 4 number out of the 5, so the probability for not getting a 3 is 4 over 5. Okay, then if we try to interpret this question here, basically you can see that the 3 obtained for the first time on the 8th spin. That means the number of spin, the first 3 appear at 8, x equals to 8, the 8th spin, which means that the first 7 spins, all of us having not a 3. So that means, let's say for the first spin, if I'm not getting a 3, the probability will be 4 over 5. Correct or not? To get a 3 is 1 over 5 Therefore, not to get a 3 is 4 over 5. And then for the second spin, I also didn't get a 3, which is also 4 over 5. Same thing happened for the third spin. And the fourth one, also not a 3. And then the fifth one, also not a 3. The sixth one, also not a 3. And the seventh one, also not a 3. Then at the 8th spin, we successfully get the first 3. So to get the probability of getting a 3 is 1 over 5. So basically this is the idea. Okay, and then of course, usually when we want to write out the step, we are not going to write out so long. So what are we going to do here is we'll just simplify it. Most of the time we'll simplify like this. So 4 over 5 power 7. Because the first 7 spin, what we get is not a 3, right? So we are having 4 over 5 power 7. And then multiply 1 over 5 for the 8th spin. Okay, so usually we'll write it in this way. Alright, then this is an overview, how we actually get the shortcut here. And just press the calculator and try to get the answer. Correct to 3 significant figure, we should get 0.0419. Okay, alright, then let's have a look for part B. For part B, they want us to find the probability that fewer than 6 spins are required to obtain a score of 3 for the first time. So again, highlight the keyword for the first time one more time. And again, you can see this keyword, it actually tells us that it belongs to geometric distribution. Still the same thing, we are having x is the number of spin, and it is geometric distribution. The probability of getting a 3 for a single spin is 1 over 5. And now we are going to get the number of spin is fewer than 6. Not include the 6. The keyword is fewer, right? So when you write the symbol, there's no equal sign. Okay, so to get x smaller than 6, we will change it become x smaller equals to 5. Okay, so why do I need to change it become x smaller equals to 5? It is because of there's a shortcut formula for us to apply in geometric distribution, which means that if I'm having x smaller or equals to r, the general formula can be 1 minus q power r. Alright, so this formula I think is not provided in the formula booklet, but you can use it in the exam so that your step is shorter. Okay, so 1 minus q power r. Therefore, before I can apply this formula, I have to make sure that I change my symbol into the smaller equal sign. So x smaller than 6, not included 6, right? It is actually having the same meaning as x smaller equals to 5. And therefore, when I want to find the probability, I can straight away take 1 minus Q power R. Q means the complement event of P, right? The complement probability for P. So Q should be 4 over 5, and then power R, which is 5. Okay, then again, try to press calculator and finalize your answer. If you want to keep it in the fraction form, it will be something like this. Or if you don't want, you can of course change it become 3 significant figure, which is 0.67. Right, so this is how we solve question number 1, which is about the geometric distribution. Right, so now we come to question number 2. Georgie has a red scarf, and then one blue and also one yellow scarf. Each day she wears exactly one of these scarves, and then the probability for the 3 colors are 0.2, 0.45, and 0.35. Okay, after that, when she wears a red scarf, she always wears a hat. And then she wears a blue one, she'll wear a hat with probability 0.4. Okay, when she wears a yellow scarf, she wears a hat with probability 0.3. Okay, so first of all, they want to find the probability that on a randomly chosen day, she wear a hat. Okay, so for this question, right, generally you can see that it is a process where first process is what is the color of the scarf that Georgie will wear, and then the color of the scarf, after the color of the scarf, right, will actually decide or affect the event that will she wear a hat or not. Okay, so from here you can see that it is a process. So usually for process, if you want, okay, to solve this question, if you want, you can try to draw a tree diagram to show all the events out clearly before you start to answer the question. Okay, but of course that's an option or a suggestion. Okay, because when you draw the tree diagram, you can see very clearly all the possible events that will happen, all right, at the end, from the beginning until the end. All right, so for me, I will try to sketch a diagram, the tree diagram, okay, to show all the possible events. Okay, so I'm having first event is what is the color of the scarf that she wear. So she's having either red, blue, or yellow. There are 3 colors here. Therefore, when I want to draw a tree diagram, I might have red scarf. Then the second color will be the blue, and the third one is yellow. And then they also tell us the probability for each color scarf. 0.2 is for the red, so I will write a 0.2 here, and then 0.45 for the blue color and 0.35 for the yellow color. Okay, so after she wear the scarves, right, will decide actually will she wear a hat or not. So when she wear a red scarf, she always wear a hat. Always means that 100% that she'll wear a hat. So here I'm having one event here. When she's wearing a hat, the probability is a 1 because always certain will happen, right? So it will be equals to 1. And then when she wear a blue scarf, she wear a hat with probability 0.4. So for blue scarf, there's a possibility that she will not wear the hat. No hat. Okay, so wearing a hat is 0.4. So not wearing a hat will be 0.6. So that the total for these branches, this pair of branches is equals to 1. So 0.4 plus 0.6 equals to 1. And after that, when she wears a yellow scarf, she wears a hat with probably 0.3. So again, this one I'm having hat 0.3, and then not wearing hat will be 0.7. Okay, so this is basically a complete tree diagram to show all the possible outcome for this question. Okay, then now I will start answer the question here. They want us to find the probability that on a randomly chosen day, Georgie wears a hat. So our final concern is what's the probability of wearing a hat? To calculate the probability of wearing a hat, if you want to use a tree diagram, right? Basically, you need to start from the beginning of the event, the tree diagram until the end. It is not allowed that we are not allowed to just calculate and focus the probability from the center. As an example, some students, when they look at the probability of hat, they might straight away take 1 plus 0.4 plus 0.3, which is wrong. Okay, so to calculate the probability for hat, you need to start from beginning, from the beginning of the tree diagram to calculate the complete probability. Okay, so you're not allowed to start halfway in the tree diagram, right? Okay, so wait, yeah. Okay, so let me list out the step. Okay, so to get the probability of wearing a hat, we are having three different pathways. The first one is this one. Okay, she wears a red scarf and also wearing a hat. So 0.2 multiplied with 1. So that's the first case. And what's the possible second result that we have? When she's wearing a blue scarf, she's also wearing a hat. So this is also considered as the event where she wear a hat eventually, right? So it will be 0.45 wearing a blue scarf multiplied with 0.4 wearing a hat. And how about the last possible result? So the last possible result is the last one, yellow, and then hat. So which means I'm having 0.35 multiplied with 0.3. Okay, then when I try to simplify my answer here, it should be equals to 0.485. Or you can write it as 97 over 200. Alright, so this is how we calculate the probability. For me, I personally prefer to draw the tree diagram out because I can see all the events that happen clearly. Okay, alright, and then again, when you want to apply the tree diagram, right, to calculate the probability, please make sure that you start from the beginning, but you are not allowed to start from the middle. Okay, so this is what we have for part number 1. Okay, then let's continue to part B. For part B, they want us to find the probability that on a randomly chosen day, Georgie wears a yellow scarf, given that she does not wear a hat. Okay, so highlight the keyword given that. This keyword basically tells you that we are going to find the conditional probability. Okay, so for conditional probability, right, the formula is, if I'm having event A, given that event A happen, what's the probability of event B happen? So the general formula for this one will be A intersect B divided by the probability of A. Okay, so the keyword is given that. Right, so from here I know that I'm going to calculate the conditional probability. Okay, given that what happened first, given that she does not wear a hat. So that means here should be not wearing a hat. Okay, then find the probability that on the randomly chosen day she wears a yellow scarf. So the event on top should be yellow. Okay, so this is a symbol for the conditional probability, right? And then to calculate the probability, please apply the formula here. A intersect B. That means I want to calculate the probability for yellow intersect with not wearing a hat and divide by the probability of not wearing hat. Okay, so the formula you can refer here. Okay, the conditional probability formula. Okay, so what is the probability for yellow intersect not wearing hat? So again, you can go up back to the tree diagram and then looking for yellow and not wearing hat. Yellow is this one, 0.35. Not wearing hat is 0.7. So you multiply the probability together. 0.35 multiplied with 0.7. And how about the probability of not wearing hat? Just now we already calculate the probability of wearing hat in part A, which is 0.485 or 97 over 200. So not wearing hat probability will be the complement for this one, right? Complement event for this one, where the probability will be 1 minus the probability of wearing a hat. Okay, and after that, simplify the answer. We are having 49 over 103. Or of course, you can change it become 3 significant figure where it should be 0.476. Alright. Okay, so this is how we solve question number 2. Okay, so question number 3. The time spent by the shopper in a large shopping center has a normal distribution. So highlight the keyword normal distribution. Okay, so with mean 96 and also the standard deviation 18. Okay, find the probability that a shopper chooses and random spends between these minutes in the shopping center. Okay, so I think the keyword is very, very obvious. So they already tell us that this is a normal distribution. Okay, so let's say the x is the time spent by the shopper. They are normally distributed and then the mean is 96. Standard deviation is 18. So I will put it as 18 squared because the number here, the parameter here, I have to put it with variance, right? So variance should be 18 squared. Alright, then after that they want us to find the probability. So put probability as P. The shopper choosing a random spans between these minutes. So the number of minute or number of time spent is between 85 until 100. Okay, then to calculate this probability, basically what we need to do is, this is a variable x, right? And then we know that it is normally distributed. Therefore, before we can calculate the probability, we have to standardize it. So to standardize it, we have to change it become z. X, we need to change become z. So how to change it become z? So you are using the value of x minus the mean, so minus 96, divided by standard deviation, which is 18. Same thing happened for the 100. So 100 is the x, right? So standardize it. You will need to take the 100 minus the mean divided by standard deviation. Okay, so from here, I'll get the probability where it should be equals to, try to press calculator, and then we'll take the z value correct to 3 decimal places. So negative 0.611, then z, then 0.222. Okay, so for this question, right, basically they want us to calculate the probability from negative 0.611 until 0.222. Okay, I assume that this is 0.222, and then let's say this value is negative 0.611. So basically I want to find the area for this part. Okay, so to find the shaded area here that I showed in the normal distribution, in the normal graph here, okay, this is a shaded area that I want to find, right? Okay, according to the values provided in the normal distribution table in our formula booklet, they only provide us the value that is smaller than a certain value. So as an example, if let's say I want to find the shaded area here, basically what I need to do is I maybe can consider to take this area, this dark blue area. So what is this dark blue area here? When I want to write it out, it should be probability of z smaller than 0.222, right? So the whole dark blue area is the area smaller than 0.222. So after I found the dark blue area, I need to minus it with something else to get the shaded area. So what I need to minus is I need to minus this green color, or maybe I put it as red color area. So this red color area, when I want to write it out, it should be z smaller than negative 0.611. Okay, so this is what am I doing here. So I try to use the area smaller than 0.222 minus the area for negative 0.611. Okay, then after that, to get this probability z smaller than 0.222, right? You can straight away find out the value from the normal distribution table. Looking for the value of z is here, 0.222. So you go for 0.2 and 2. So what do you get here? 5871. Then another 2 at the back, where you need to add the 8 at the last digit of 5871. So if you take 5871 plus the 8, you have 5879, right? Okay, so when you want to change it become the probability, it will be 0.5879. Minus, I just copy the minus. And then for this particular value, the area, z smaller than negative 0.611, if you refer to the diagram here, the value of z, they didn't provide any negative value. Therefore, I have to change it become positive value and find out the respective or the tally area, okay? The similar area. So for this area, the red color one, smaller than negative 0.611, basically it will be equals to greater than 0.611. So this area and this area will be the same. Okay, so to get the area for greater than 0.611, you have to take 1 minus the area smaller than 0.611 because our table provide the area smaller than. Okay, so I go for the table again, looking for 0.611. 0.61 is this one. And then at the back, I need to add what digit? I need to add a 3 at the last digit. So 7291 plus a 3. So I'm getting 7294. Okay, so go back to our question. I have to take 1 minus 0.7294. to get the area which is greater than 0.611. Alright, so if you just try to press calculator and simplify your answer, 0.3173, and I would like to change my answer correct to 3 significant figure, it will be 0.317. Okay, so this is how we actually solve this first question here. Alright, so in your step, basically, you need to make sure that you show the step where you try to standardize the variable from x become z. And then the next one will be you need to show the area and the value that you actually get it from the table itself. Alright, and of course the simplified answer for the final answer. Okay, alright, so let us proceed to question number 3b. Okay, so for question number 3b, they are saying that 88% of the shoppers spend more than T minutes, highlight the keyword more than T minutes in the shopping center. Find the value of T. Okay, so for this question, right, if I try to express it in a symbol form, the time spent is x, okay? Time spent is x more than T, so that means x greater than T. The probability is 88% or 0.88. Okay, so this is basically what I get for the symbol if I read the question from here, from the sentence, from this sentence. Right, if I translate into a symbol, it will look something like this. Okay, so now our aim is to find out the value of T. Okay, so before I find out the value of T again, I know that it is the time spent, right, is actually normally distributed, therefore I have to change it become Z first. Again, how are you going to change it become Z? You take the value of X, which is a T now, minus the mean. So minus 96 divided by standard deviation 18, and it is equals to 0.88. Alright, so before I want to find the value of T, right, from here onwards, they are having many different ways to find out the value for T. So for my one, I will use a diagram to help me. Okay, so I know that when I'm having a variable Z, the center value is a 0 or the mean is a 0. Okay, 0.88 is a large value. Okay, it's a large value. And then I'm having the area where Z greater than a certain value equals to a large area. That means if I want to draw it in a normal diagram, this value itself will be T minus 96 over 18. Okay, and the area more than this particular value of Z is equals to 0.88. So this whole area here is 0.88. And now I need to find out the value of Z. This is the value of Z. Okay, by using the area 0.88. So please take note, this is the value for area itself. Okay, when I want to find out the value from the normal table, the 0.88 refer to probability, which is actually area, this one. Okay, and we want to use the value from here to find back the value of Z outside. Okay, so don't do it the other way now. Some students, they feel confused. They looking for the value of Z 0.88, then they read the value inside, which is wrong. Okay, so we have to do it the other way around, which means that we are looking for 0.8 from the table here inside, and then we look for outside value, which is Z. Okay, so let's have a look for 0.88. What's the nearest value to 0.88 but smaller than it? I think should be this one, right? 0.8790. So this value itself, 0.8790, I read out the value and I get 1.1 and then 7, 1.17. After that, I need to add a 10 to get 0.88, right? If I need to add a 10, that means the third decimal place for the value of Z is this one, 5. So if you try to read the value itself, it will be 1.175. 1.175 for the value of Z. Okay, so if I come back to my step here, I know that the value of Z is 1.175. But if I look at my diagram here that I draw just now, so this value should be a negative value, right? And since I get 1.175 for the value of Z, it should be negative 1.175. It is because of this particular value is below 0. That means on the left hand side of 0, okay, it should be a negative value. So now I would like to compare my Z value. So Z minus 96 over 18, I know that the value is equals to negative 1.175 that I get it from the normal distribution table just now. Alright, then to get the value of t, what we need to do is move all the number to the other side and simplify them. You'll get 74.85. Alright, so I think this is a whole number, right? Okay, so you are allowed to leave your answer like this, where t can be equals to 74.85. Alright, so this is how we solve question number 3. Okay, so let's discuss question number 4. I have a random variable x, and then the value of x takes the value 1, 2, 3, 4 only. Okay, then the probability of x for every single value x is this one, kx multiplied with 5 minus x, where k is a constant. So first they want us to draw up a probability distribution table for x in terms of k. Okay, so we need to draw a table. Alright, and then for the first row of the table, we will want to list out the value of x. Okay, so according to what we have here, x can take 4 values here, 1 or 2 or 3 or 4. So I have x can be equals to 1, x can be equals to 2, x can be equals to 3, and also the 4. And then to calculate the probability for the value of x, the formula is this one. So that means when x is equals to 1, to calculate the probability, you need to substitute the 1 into the x. So you're having 1k, 5 minus 1, you get a 4, right? So 4 times 1 times k. Therefore, you are having 4k. Okay, so the probability for x equals to 1 is 4k. So you do the same thing for the rest of the value for x. Okay, when x equals to 2, substitute the value in x equals to 2 into this particular formula for probability. So you're having 2 times 3, which is equals to 6. 6 times k, you get 6k, right? So when x equals to 2, the probability is 6k. Okay, then again you do the same thing for x equals to 3 and x equals to 4. By right, you should get 6k also for x equals to 3. Then you'll get 4k for x equals to 4. Alright, so this is what we have for the probability distribution table, and then the probability is shown in terms of k. Alright, okay, so I think this is quite straightforward. You just need to substitute all the value given in the question into the formula given to get the probability. Okay, then how about we go to part number B. Okay, so for part number B, they want us to show that variance is equals to 1.05. Okay, before you can calculate the variance for x, we need to know what is the probability for every single value of x here first. Okay, so first of all, you need to know that when you try to add all the probability together, right? All this probability, if you add them together, it should be equals to 1. Okay, so first of all, I want to find out the probability for all the value here. So I'm having 4k. First probability, second probability 6k, the third one 6k, the fourth one also 4k, and total should be equals to 1. So from here, the value of k that you get is 1 over 20. Okay, and then if you try to substitute k equals to 20, right? 1 over 20 into the table. Okay, so now I put it like this, x and p. X I have value 1, 2, 3, 4, right? Okay, so the first probability is 4 divided by 20. 4 multiplied with 20. 4 multiplied with 1 over 20, sorry. 4 multiplied with 1 over 20. So you have 4 over 20, which is 1 over 5. Okay, if you want, you can write as 4 over 20. Then the 2 is 6 over 20. 3 is also 6 over 20. And the 4 is 4 over 20. So by right, my table now should look something like this. Okay, then to calculate the variance x, right? First step, we actually need the mean, the expected value for x. So the expected value of x, the formula is x multiplied with p. That means you try to take the value of x, multiply with the value of p, and you add every single value together. So that means if I list it out in detail, I'm having 1 x, which is multiplied with p, 4 over 20, then plus, summation means plus, right? So the second value is 2, and then 6 over 20. Okay, you can refer to the table here. Then the third value is x equals to 3, multiplied with 6 over 20, and the fourth value is 4, multiplied with 4 over 20. Okay, simplify this value, we are getting 5 over 2. Okay, so we will need to use this value later when I want to calculate the variance of x. Okay, then the second value that I need is expected value for x squared, which means that I try to square the x and multiply with the probability. So same thing happened here. I take the first value x, which is a 1, and then before I multiply with the probability, I need to square it first. So 1 squared, which is x squared, multiply with the p, which is 4 over 20. Same thing happened for the second value. Second value for x is x equals to 2. You square it and only you multiply with the probability. So you do the same thing for the rest of the value of x. And this is how we actually get the expected value for x squared. Okay, so by right, if you didn't do any careless mistake, it should be 73 over 10. Okay, then to calculate the variance of x, basically the formula involves these two, expected value of x squared, expected value of x. So the formula is expected value for x squared minus the mean squared, where you are having 73 over 10, then minus the mean that we get just now is 5 over 2, right? So 5 over 2, and then I squared also. Okay, if you didn't do any careless mistake, by right, you should be able to get the value 1.05. So it is equals to 1.05 for this particular question. Okay, so this is how we solve question number 4. Alright, so let's discuss question number 5 now. We have a driver records the distance traveled for the 150 journeys. And then the distance, so they are talking about the distance of the journey, right? Correct to the nearest km are summarized in the following table. Okay, so when you're talking about distance, right, it is actually a continuous random variable. Continuous random variable. Okay, then before we want to answer the question, right, they want us to actually sketch or draw a cumulative frequency graph. So to draw a cumulative frequency graph, my y-axis is actually cumulative frequency, and the x-axis should be the upper class boundary lah. So we are looking for the upper class boundary for my x-axis. Okay, then of course I have to set up the question first before you can start drawing it. Okay, so first of all, for the class interval that is given in the question, right, I need to check and see whether are they class boundaries or not. So how to check whether are they class boundary or not? So first of all, please check at the upper limit of the first class and also the lower limit of the second class. We realize that these two values are different. So when you have two different values here, right, so that means the data provided in the table is class interval. Alright, so it is class interval. Therefore, when we need to do some adjustment to make my class interval become class boundary. So how to adjust it become class boundary? All the upper limit I have to plus 0.5 and all the lower limit here I have to minus 0.5. Okay, so that I can change it become upper class boundary. But there's a very special number here. When you're having the class interval that starts with 0, okay, for the continuous random variable, we have to remain it as 0. We cannot change it become a negative value. But for discrete random variable, then we are allowed, okay, or we can change it become negative 0.5. So this is a small note that you need to take, okay, because later it will affect our calculation for mean or maybe standard deviation. All right, so now let us try to write out the class boundary first after I adjust the value. Okay, maybe for me, I will do it at the side here, by the side here. Okay, so what is my class boundaries? Okay, so for my class boundaries, the first class that I'm having here is 0 until 4, right? After adjustment, I will have 0 until 4.5. Then the second class, it will become 4.5 until 10.5. Then the third class is 10.5 until 20.5. Next one, 20.5 until 30.5. And we do the same thing for the rest of the classes. Okay, all right, so this is our class boundaries for the classes that we have here. And then now we need to take up the value for upper class boundary. So the first upper class boundary that we take, we always need to start it with 0. So this is a 0. The second upper class boundary will be 4.5 and so on. Okay, so I will write here, I'm having the upper class boundary Okay, then I will have the cumulative frequency. Okay, so for upper class boundary, the first one I assume that it is a 0 and my cumulative frequency is 0. Then the second point, the upper class boundary is 4.5. So you can see from here, this is the upper class boundary, right? 4.5. And then the respective cumulative frequency will be the first one, which is 12. Okay, so for the next class, the upper class boundary is 10.5. And the cumulative frequency, you need to take 12 and then plus 16 because we accumulate the frequency. So we take 12 plus 16 and therefore we will have 28. So I do the same thing for the rest of the classes. So the next upper class boundary is 20.5. And then I try to add the first three frequency all together and I will have 60. Okay, so we'll do the same thing for the rest. So the next class will be 30.5, where the cumulative frequency will be 126. Next one will be 40.5, and the cumulative frequency will be 146. And then maybe I need to adjust this a little bit. Alright, then after that, the last class we are having here is 60.5. So 60.5, the last cumulative frequency will be, you add all the frequency together and you have 150. Okay, so later all this value here, upper class boundary will be my x-axis value and the cumulative frequency will be my y-axis value. Right, so we'll start setting up the graph. Okay, I will make the graph paper to be seen clearly, to be seen for the whole page. Alright, okay, so that it's easier for us to sketch it. And then for you, you can try to sketch it according to what I suggest here. Okay, so like what we mentioned, we are having the y-axis. So don't forget to label it as cumulative frequency. And then for my x-axis, I'm having the distance. Although we are putting it as upper class boundary, but basically it is also having the meaning as distance. And then it is measured in km. Okay, so now if I look at my upper class boundary, right, the smallest value is 0, the largest value is 60.5. So maybe when I try to label it, I can start it from 0, then this is a 10, then 20, 30, 40, 50, and then 60. Okay, and then for the cumulative frequency, the highest value that we have is 150. Therefore, what we can do is like we can make this one as 20 unit, then 40, and so on. Okay, so for the first point that we have, we should start from 0, 0. So we can plot the 0, 0 first. Okay, then after that, for the second point is 4.5 at 12. So you can maybe roughly measure where's your 4.5. So the center here is a 5. 4.5 will be slightly in front of 5, right? And then they are asking for the cumulative frequency 12. So 12 should be somewhere here. So I just try to draw approximately. Okay, but actually if you try to enlarge it now, you can see the value very clearly. Okay, so by right, if let's say I enlarge it, right? So the 5 is on this line. So it should be 4.5, slightly earlier than 5. And then the value is 12. So this is actually 12. Okay, so I can actually plot it very clearly. Okay, because the ratio that I'm using is easy to read. Okay, then after that, the second upper class boundary is 10.5 and the cumulative frequency is 28. So 10.5 and 28 should be somewhere here. Okay, then 20.5 for 60. 20.5, then 60 should be somewhere here. Okay, so I do the same thing for the rest of the classes. So next one will be 30.5 at 126. So 30.5 at 126, it will be quite high. It should be somewhere here. Okay, then 40.5. 40.5 will be 146. So 146 will be here. And then when you're having 60.5, the value will be 150. So it should be somewhere here. Okay, and then after that, I will try to connect all the points together. You can either connect by using a smooth curve, or if you want, you can use a ruler to join all the points together. Okay, so I try to draw it by using a smooth curve lah. Okay, so it's up to you whether you want to draw it by using the ruler or you want to draw it by using a smooth curve. Okay, then this is how our cumulative frequency graph look like. Okay, all right, then don't forget to label the cumulative frequency and also the distance, your y and also the x-axis. All right, then after that, let's proceed to part B. So for part B, they are saying that 30% of this journey distance traveled d km or more. They want us to use the graph to estimate the value of d. Okay, so for this question, right, I need you to highlight the word or more. More. Okay, for your information, you need to know that for any type of cumulative frequency curve that we are drawing, that I showed you just now, right, the graph only shows us the value which is less than. Okay, all the values shown in the graph that we draw just now are showing the value for less than. Therefore, when they're asking for more than, we need to adjust the question a little bit, become the meaning of less than. So as an example, when we are having 30% travel more than dkm, right? Travel more than dkm. To calculate or to estimate the value of d, I need to change it become how many percent are less than dkm. If 30% are more than dkm, that means our 70% travel less than dkm. Agree or not? Therefore, when you want to estimate the value, we have to calculate the 70% of the total frequency. So to estimate the value, I need to take 7%, which is 7 divided by 100, multiply with total frequency, 150, and therefore I get 105. That means when I want to estimate the value for D, I need to look at the value for 105 from my diagram or from my graph and estimate the value for the distance. So I go back to my question here, looking for 105. So where's 105? It should be somewhere here. Okay, then I try to draw a line that touch my curve that I draw, and then I try to read the value at the x-axis. Okay, so please take note that in exam, make sure that you show clearly the line and the value that you started to read your graph. Okay, then just follow what you have in your graph and then try to get the value. So for me, I'm getting this value here. Okay, then when I try to read the value, it is more or less like 26. It is just an estimation. Okay, so I can see that if I read the value from this part, I get maybe a value around 26. Therefore, the answer for the D here is actually 26. Then for me, I will always put, because they already mentioned the km here, right? So you don't need to put km, is okay. So it should be D equals to 26. So according to the graph that I draw, okay, I get 26. So if let's say you are estimating the value from your graph, right? The value shouldn't be too far away from this. If let's say the value is too far away from the answer provided, right? That means something wrong with your graph. Okay, so you can double check and see whether is there any problem with your graph or not when your estimated value is too far away from what the marking scheme suggested. Right, so this is how we answer part number B. After that, we are going for part C. Okay, so for part C, they want us to calculate an estimation for the mean distance traveled for the 150 journey. Okay, so to calculate the value of mean, I actually need the midpoint. Okay, so to get the midpoint, maybe I need this. Okay, so I will bring it down here. Okay, so to get the midpoint, basically we are getting it from the class boundaries. Okay, so just for your information, if you want to get midpoint, what's the formula for us to get the midpoint? We need to take the, lower class boundary plus upper class boundary divided by 2. So for the first class, right, the midpoint that I have is actually should be 2.25. Okay, this is for the first class. So to get the midpoint for the second class, you take 4.5, the lower class boundary, plus the upper class boundary 10.5 divided by 2. So from there you will get the midpoint, which is 7.5, and so on. Okay, so for me, I know I will not show every single midpoint here. I will show it in my step. So for your information, to calculate the mean, okay, for the set of data, what I need is, I need this formula. So to get the mean, it is actually, I need to take summation of frequency, multiply with the midpoint, and then divided by the total frequency. Okay, X is the midpoint, F is the frequency for that particular class. Right, so I will start the calculation here. Okay, so when I want to calculate the mean, usually I will write it out like this. Summation of fx, right? I will list out everything here. For the first class, frequency is 12. So midpoint is 2.25. So I will take f multiplied with x, 12 multiplied with 2.25. So my first midpoint is 2.25. You can see that, right? Okay, after that, the second class. So what is the frequency for the second class? You can go back to the data. Second class frequency is 16. Okay, so I will take frequency 16 multiply with the second class, which is the midpoint of the second class, which is 7.5. Okay, then for the third class midpoint is 15.5. Okay, then the fourth one, then the fifth one, and so on. Wait, okay, so I'll try to move it further. Okay, then the next one is 20 multiply with 35.5, and the last class frequency is 4, then multiply with the midpoint 50.5. Okay, then divided by the total frequency here, so the total frequency is 150. Okay, then just try to press calculator carefully, and then by right, the number on top is 3238 divided by 150, and I want to correct it to three significant figure, where the answer for the mean should be 21.6. Alright, so this is how we actually calculate the mean, and we need the midpoint. Okay, so for this question, just take note that for the first class, because it belongs to the continuous random variable, the first value, the lower boundary here, right, cannot be negative value, so you should start it with 0. So 0 plus 4.5 divided by 2, and the midpoint should be 2.25. Okay, so this is how we answer question number 5. Okay, so we come to question number 6 now. We are having, we want to find the total number of different arrangements. So maybe we can highlight the word arrangement, which it tells us that this is about the permutation. Okay, so for permutation question, later you will need to use maybe something factorial, like n factorial, or most of the time your step will involve, your working will involve NPR. Okay, so we are having arrangement for the 11 letters in the word caterpillar. Alright, so before you can arrange the word, what we need to do is we need to figure out how many identical letters that we have. So if I try to figure it out, we are having actually 2A in the word caterpillar, then 2R, and also 2L. And after that, we are having all the single letter, which is C, T, E, then P-I. Okay, so first of all, we try to analyze what kind of letters do we have first. And now only we start to arrange the letters. We are having 11 letters in total, right? So you can see very clearly we're having 11 letters in total. When I want to arrange 11 letters or 11 items, what we have is 11 factorial. Okay, and then divided by what? So divided by, when we are having the identical letters such as 2A, 2R, and also 2L, okay, we need to divide it by 2 factorial, 2 factorial, and 2 factorial. Okay, because no matter how you arrange the 2A and 2R, 2L, right, basically they will look the same, the result will be the same. Therefore, I have to divide all this. Okay, so this is because of 2A, because of 2R, and also because of 2L. Okay, after that, press calculator. By right, you should get this value, 4989600. Okay, all right, so this is how we solve it. Let's have a look for part 2, for part B. Okay, so for part B, they want us to find the total number of different arrangement also, right? Okay, so I've put it down first. Okay, they want us to again find out the different arrangement for these 11 letters, and then the R at the beginning and R at the end. Then after that, the 2A are not together. Right, so when they already have the restriction for us, where the first letter must be the R and also the last letter must be the R, which means that we no need to consider the arrangement of R anymore because they are fixed there. Okay, so we will only consider the 9 letters in between the R. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, when we want to arrange these 9 letters here, they also give us some restriction where the A are not together. So when the A are not together means that the A must be separated. So when I want to deal with the case where the A must be separated, right, I will actually arrange the other letter first. Then I'll put the letter A at last. Okay, so here I don't have any R anymore. The letter 2A, I want to keep it at last. So now I need to arrange how many letters first. So there are 2L and also the 5 different letters here. So 5 plus 2, 7, right? So I want to arrange 7 letters. So 7 factorial. But out of these 7 letters here, there are 2 letter L which are identical. Therefore, I have to divide it by 2 factorial. Okay, after that, so now the first part is I already arranged the 7 letters with 2 repeated letter L. After that, now I want to put in the letter A. So when I simply, when I arrange my 7 letters here, right? And now I want to put in the letter A, I have to ensure that I have to make sure that they are separated. So to separate the A, I need to maybe put the A into the spaces between the letters. So you can see that all the arrows here are the available spaces to place 2A. How many places do I have here? So if you count, it should be 8 letters. 8 space, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 8 spaces, right? So to arrange the letter A, I have 8 spaces and I want to arrange 2 of the letter A inside. So I'm having 8B2 and then divided by, because of the 2 letter A are identical also, therefore I need to divide it by 2 factorial as well. So when I multiply them together, the answer that I get should be 70560. Okay, then another way to interpret this question is also this, another way of writing out the working line. It can be, we have the 7 letters first, and then divided by 2 because of the 2 identical L. And now if I want to put in the letter A, right, for the first letter A, I have 8 space here. So for the first letter A, I can place anywhere, okay, between the 8 spaces. So the first letter, I'm having 8 possible position to be placed. Alright, so if I place the first A somewhere else already, maybe here, so you can see that the available space now becomes 7. So to place the second A, I'm having 7 space only, or 7 position. And again, because of the 2 letter A are identical, therefore after I arrange them, I have to multiply it with, divide it by 2 factorial as well. So the answer is the same actually, just depends on how you interpret the question. Alright, so for both answer will give you 70560, both method. Alright, okay, so this is what we have for part B. Let us proceed to part C. Okay, so for part C, wait, okay, so I try to bring this down again. Okay, so for part C, what they want us to find is, okay, they want us to find out the number of different selections. So highlight the keyword selection. Okay, so this actually tells us that this particular question is about combination, and very likely our step will have NCR later. Okay, so the total number of different selection of 6 letters, I want to have 6 letters in total from the 11 letters, and then contain both R must be included. Then the other restriction is at least one A and also at least one L. Okay, so for information, right, when we want to deal with the combination question, and if we are having the identical letters inside, we generally have to list out the possible outcome case by case. All right. So for the first case is I have both R inside. Then they want to have at least one A and one L, right? So maybe for the first case, I assume that I'm having one A and one L. And total I need 6 letters. Therefore, I still have 2 letters to be selected and placed. Then how about the second case here? So for the second case, both R are included. So maybe now I want to include the case where I have 2A and 1L. So I still have 1 letters need to be placed besides the A and L. Okay, then the third case, I can also have both R inside. Then I have both A and both L in the selection. So there are 6 letters already. After that, the last one, I have both R inside, 1A and 2L. Okay, so all these are the possible cases that I have. I have to try to list out the cases according to the identical A and L that I have and fulfill what they want us to achieve in the question. Alright, so there's no shortcut. Basically, we need to list out case by case. Okay, then now, when we want to write out the working, right? Okay, so for the first case, R, R, A, L are fixed in the letters already. So I just need to compare, or I just need to select 2 letters to be placed in these 2 letters. So to place in these 2 letters, we only want to consider the other letter which is not A, R, and L. We only want to consider C, T, E, P, I. Because if we include the A, R, or L inside our selection, then later you might have the repeated case where both A appear or both L appear, right? Okay, so I will only focus on these 5 letters here. So for these 5 letters, I want to choose 2 and place them in the 2 letters here, 2 empty space here. So it will be 5C2. Simply happen for case number 2. For this particular letter, I only want to consider them from this 5 letter here, which is 5C1. For the third case, you can see that it is the complete 6 letters already. So this is one method or one combination. And after that, for the last case also, I'm having 1 space here, and this space I want to select the letter from C, T, E, P, I. So it also will be 5C1. Okay, then just try to get the value here. I'm having 5 for this, 1 and 5. Therefore, to get the total number of combination, you just try to total all of them out and you should get 21. So we are having total 21 different combination. When I want to select the word, select 6 letters from the word caterpillar with this restriction. Alright, so this is how we get the answer for question number 6. Okay, so now we are at the last question for this paper. We are having 400 students in a school, okay, in a certain country, and then each student will ask whether they prefer swimming, cycling, or running, and also the results are given in the table like this. Okay, so a student is chosen at random. They want us to find the probability that the students prefer swimming. Okay, so we need to calculate the probability of the students who prefer swimming. Okay, so to calculate the probability for swimming, we have to actually add all the swimming value, the frequency, which is 104 plus 31, divided by the total, the grand total of the students, the total number of students, which is 400, and we should get 0.3375, or you can correct it to 3 significant figure where it will become 0.338. Okay, so this is what you have for first question, which is quite straightforward. And then now for question number 2, they want us to determine whether the event student is male and also student prefer swimming are independent or not, justifying your answer. Okay, so to verify this, to test whether are they independent or not, the events these 2 events are independent if our probability for male student multiplied with the swimming probability is actually equals to male intersect with swim. If we are having this result, basically it means that these 2 events are independent. Okay, so we have to prove this and see whether these 2 events are independent or not. Okay, so we'll start with we already have the swimming probability, and now we are interested to find out the male probability. Okay, so the probability of selecting a male student will be you total up all the male students frequency, 31 plus 57 and 92. If you add them together, you should have 180. Then divided by 400, the probability of getting male is 0.45. So we have the swimming one, we have the male probability, and now we are looking for male intersect with swim probability. Okay, so let us have a look at how to calculate the male intersect with the swimming probability. Again, we have to look for the cell where male and swim intersect with each other. So if you have a look here, male and swimming will be 31. So it will be 31 divided by 400. Okay, so when you're having 31 divided by 400, right? Your value for this is 0.775, 0.0775. Okay, and now I want to test and see, okay, compare and see whether I'm having this result or not. So what am I going to do is I try to find out the probability of male multiply with the probability of swim, and both value we already get just now, right? So the probability of swimming is 0.3375, male one is 0.45, so I will write 0.45 multiply with 0.3375. Okay, and then for this value, I will get 0.152. And if I try to compare it with the male intersect with swimming probability, you realize that it is not equals to the probability of male intersect swim. Because this one, we just now get the value 0.0775, right? Okay, right. So since these two values are not the same, therefore, we can make a conclusion where the event of the student is a male. Okay, and the event that the student prefers swimming okay, are actually not independent. So are not independent because the value are different. Okay, for male multiply with swim, compare it with male intersect with swim. So are not independent. Okay, so basically all the steps above here are justification, and then this is the conclusion that we have. Alright, okay, so this is what we have for 7a part 2. Let us proceed to 7b. Okay, so for 7b, they are saying that on average, all the school in this country, 30% of the students do not like any sport. Now we are having 10 students selected from the country, and then at least 3 of the students, something happens. 3 of the students do not like any sports. So again, from this structure, right, we are having 30%, which can be converted into a probability. Okay, for any particular students selected, there's a 30% chance that they do not like any sports. And now I select 10 students. Out of the 10 students, at least 3 of them, something happened. So for this kind of structure, basically it belongs to binomial distribution. Okay, so it is binomial distributed, and then the total number of trial is 10 because we select the 10 students. And then the P for any single student do not like the sport is 0.3, which is 30%. Alright, so this is our N for 10, this is our P. And now they want us to calculate the probability that at least 3 of these students, so number of students do not like sports, more than or equals to 3. So the keyword at least include the 3. So when I want to write the symbol, it should be greater or equals to 3. Okay, so if let's say I want to have x equals greater or equals to 3, right, I need to calculate the probability from x equals to 3, x equals to 4, x equals to 5, until x equals to 10, because our total number is 10 students, which is quite long. So for me, I would like to take 1 minus 0, 1, 2. That means I will take the total minus the case where x equals to 0, x equals to 1, and x equals to 2 to get the answer. Okay, so I will have 1 minus x equals to 0. So when x equals to 0, it will be 10c0, p power 0, so p is 0.3 power 0, and also the q power 10. Then minus 10c1, 0.3 power 1, 0.7 power 9, and also 10c2, 0.3 power 2, then 0.7 power 8. Okay, so I want to minus x equals to 0, x equals to 1, and also x equals to 2. Alright, and this is equals to the probability of x greater or equals to 3. Okay, so just try to press the calculator carefully and correct your answer to 3 significant figure. Your answer should be 0.671. 617. Right, so this is what you have for binomial question here. And then if we proceed to part number 2, now instead of 10 students, right, I actually select 90 students from this country and then highlight the keyword using an approximation to find the probability fewer than 32 of the students do not like any sports. So again, if you look at the structure again, you are having a greater number of students, which is 90, and then fewer than 32 of these students, something happened. So by right, it is still originally a binomial distribution, just that the n now is 90, which is larger. And then the probability of do not like any sports is still the same, which is 30%, or you can write as 0.3. And when you are having n is greater than 5, n is greater than 30, and then MP and NQ are smaller than, MP and NQ are greater than 5 also, we basically can change the binomial distribution become normal. Okay, and also the keyword here, they are saying that use an approximation. It already gives us a hint that you have to change binomial become normal actually. Alright, so to get the normal, the first value here in the parameter should be, the first parameter here should be mean, right? So you take 90 multiply with 0.3. So 90 multiplied with 0.3, you get 27. And after that, to get the variance, it will be NP cubed. So 90 multiplied with 0.3 multiplied with 0.7. So you should have 18.9. Okay, so just to recall back, this one is actually n times p, and then this is actually n, p, and q. Okay, then now we continue to find out the probability. They want us to find the probability for x fewer than. So fewer than, if I write the symbol here, it should be less than 32. Okay, so x less than 32, and this is binomial distribution, right? By right, it is originally discrete random variable, and then for normal distribution, it is continuous random variable. So when we want to change the distribution from discrete to continuous, we actually have to do do the continuity correction. For continuity correction, x smaller than 32, after I correct it, it will be 31.5. Okay, and after that, for x smaller than 31.5, only you want to find the probability. When you change it become normal distribution, you have to standardize your variable so that you can use the standard normal table to find the probability, right? So from the x, you want to change it become z. Okay, so this is the value of x, 31.5. To standardize it, you have to minus the mean, which is 27. Just now we did get the value here, right? Divided by standard deviation. 18.9 is variance, so divided by standard deviation will be square root 18.9. Okay, and from here, I will get the value z smaller than 1.035, correct to 3 decimal places, and after that, I will want to get the probability from the normal distribution table. So 1.035, let's have a look from the table. The value of z is here, right? So we are looking for 1.0. 1.0 is here. 1.03, so this is 1.03. If I read the value, what I get is this one, 8485. And after that, 1.035, we have to look at the 5 at the back. And then we need to add the value 12 to the last 2 digits of our value here. So 8485 plus 12. Okay, so you are having 8497. Alright, that means our probability for this value is 8497, 0.8497. And again, correct your answer to 3 significant figure, it will become 0.850. Okay, so this is basically how we get the probability from the normal distribution table, and please take note on all the small details here. Alright, okay, so this is what we have for the solution for this particular paper. Alright, thank you very much for watching this video.